In this video, we will see how to calculate instantaneous velocity and instantaneous acceleration. So here the first one, find the instantaneous velocity of an object at a time t equal to 4 seconds whose position is given by xt equal 12 t to the power of 5 over 2 plus 3t square plus t. So in order to get instantaneous velocity, we need to do the first derivative of the position. So that is dx over dt. We'll do the derivative of dx of the position. So let's write the function. It's 12t to the power of 5 over 2 plus 3t square plus t. Then let's do the power rule for the derivative. So 12 times 5 over 2 t to the power of 5 over 2 minus 1 plus 3 multiplied by the power comes in front times t to the power of 2 minus 1 plus t is having a power of 1, so 1 will come in front, t to the power of 1 minus 1. Now let's just simplify it. This will be 6 times 5 gives us 30 t to the power of, so 5 over 2 minus 1 will give you 3 over 2 plus 3 times 2 is 6, t to the power of 2 minus 1 is 1 plus 1, because this t to the power of 1 minus 1 is going to give you t to the power of 0, which is equal to 1. Now they said that we have to find the instantaneous velocity at t equal to 4. That means we'll put in place of time, we'll put 4. So 30 times 4 to the power of 3 over 2 plus 6 multiplied by 4 plus 1. I'll just use my calculator to get the value for this. That's 30 times 4 to the power of 3 over 2 and then plus 6 times 4 is 24 and then plus 1. That gives me the answer as 265. So 265 meter per second. Now in this second question, we want to find instantaneous acceleration. So find instantaneous acceleration of an object at t equal to 2 seconds if the position of the object is given by. So we have two positions given, and for each option we want to find what's the instantaneous acceleration. Now if position is given to us, we need to first find the velocity and then find the acceleration. So we have to do the derivative 2 times. So first we'll find the velocity function. That will be dx over dt. Again applying the power rule, 3 times 2 t to the power of 2 minus 1, and because this is a constant, its derivative will be 0. So this will be 3 times 2 is 6, t to the power of 2 minus 1 gives me 1 as the power. Then I have to do acceleration, so let's do the second time the derivative for velocity. So one more time we have to do the derivative, and that's the derivative for velocity. So let's do that. That will be because it's just 60, so 6 multiplied by 1 multiplied by t to the power of 1 minus 1. So I'm going to get the answer just as 6. I don't have to worry about the time because there is no time variable in the acceleration function. So that's my final answer, 6 meter per second square. So you can just write acceleration at 2 seconds will be 6 meter per second square. In the next one, it's a little bit more complicated in the terms. Like it has 3 terms here. Here you had only 2 terms. So we have to again do the same thing because we are finding the instantaneous acceleration. So we will first find the velocity. So Vt is equal to dx over dt. That will be 10 times 3 times t to the power of 3 minus 1 minus 3 times 2 times t to the power of 2 minus 1 Then for constant, the derivative will be 0. So that will give us 30 t to the power of 3 minus 1 is 2 minus 6 t to the power of 2 minus 1 is 1, and that's it. Then we have to do acceleration, so we have to do the derivative for velocity function. So that will be 30 times 2 times t to the power of 2 minus 1 minus 6 times 1 times t to the power of 1 minus 1. So that will be 30 times 2 is 60 t to the power of 1 minus 6 t to the power of 0 will be 1. So I just get 6. And then because I want to find at t equal to 2, I can write a at 2 seconds will be 60 times 2. In place of time, I'll put 2 minus 6. So that will be 120 minus 6. That will give me the answer as 114. So 114 meter per second square. Next, let's do one more. In this case, we can see that we have been given the velocity function directly, but there are some powers and some roots here. We want to find what's the instantaneous acceleration. So we'll do AT, which is dv over dt. So 20 times 3 over 2, applying the power rule, t to the power of 3 over 2 minus 1 minus 4. Now this square root t I can write as t to the power of half. In terms of power, the square root becomes half. So 4 times 1 over 2 t to the power of 1 over 2 minus 1. So that will, I'll just simplify it a little bit. So this will give me 10. So that will be 30 t to the power of 3 over 2 minus 1 will be 1 over 2 minus, this will cancel out. So 2 t to the power of 1 over 2, that is half minus 1, will give me negative half. Now I want to find acceleration at 4 seconds as the question says. So I will put 34 to the power of half minus 2, 4 to the power of minus half. Okay. Now you can use the calculator, but I'm just going to do first the roots. So this is square root of 4 minus 2, because this is having a negative power. We can see it's negative power, so I can take it to the denominator. That will be root of 4 like this. So that is 30 times square root of 4 is 2 minus 2 over 2. That's going to give me 60 minus 1, which is equal to 59. And remember, we are calculating acceleration, so 59 meter per second square.